Hello everyone, I'm Faiz.
I'm Helmi.
I am Farah.
I'm Fatin.
I am Patricia.
And I am Nabila.
And we are from RJ45.
Today we will be discussing about computer history, electronic era, future generation, future computer. Without further ado, let us begin. First, we will briefly talk about past computer generation.
First generation begins in years 1946 until 1957. At that time, computer uses vacuum tube. In 1958 until 1964, transistors were used as the computer technology. That is the second generation for computers.
Third generation began in 1965 and ended in 1971. Integrated circuit were used in that age. The latest generation, which is the fourth generation, the integrated circuit was replaced with a very large scale integration or VLSI. So, what do you guys think about the future generation computer is going to be?
In the future, the microprocessor technology will be changed to DNA computer or quantum computer.
That's true. In addition, there will be a better memory because we will be using magnetic RAM.
Let's take a look at quantum computer. This is D-Wave 2X built by D-Wave system. The processor has 1000 qubits and can evaluate up to 2 to the power of 1000 solutions at the same time. It also has a refrigerator known as the fridge, designed to reduce the temperature of the quantum processor's environment to near absolute zero.
Oh, the one that Google and NASA are using right now to solve complex algorithms as well as solving other problems, right?
Yep, that's right.
Although quantum computers are powerful, using it for playing video games or reading newspapers on the web is wasting. Quantum computers are best used to solve optimization problems, searching for our big data, design better drugs and new material, and also best for cryptography.
See, I told you before, magnetic RAM will also be used in the future.
Wait, what is magnetic RAM?
MRAM or magnetic resistive random access memory is a method of storing data bits using magnetic charges instead of electrical charges used by DRAM or dynamic random access memory.
Based on my reading, companies like IBM, Eversteen, and Intel has been researching this technology years ago. MRAM wasn't that popular today, but in the future we are expecting it to be commonly used inside our personal computer.
Hey, did you guys know that in the future there will be a specialization knowledge and consideration?
What's that?
It means that the programming made the doctors, lawyer, and teachers' job much more easier.
Wow! The future generation is so awesome! Did you ever heard of parallel computing before?
They say that in the future generation will be an advancement in parallel processing. In other words, the computer will use parallel processing to combine sound, image, and data from various sources.
Okay everyone, to get better understanding in parallel computing, let's watch a video.
Hey guys, and welcome to another video from Fast Take Scale series. In this video, I'm going to talk about a very interesting concept, which is parallel computing. This topic, or this way of computing, I should say, has been very popular in the past years, and there's a specific reason why, which I'm going to discuss in this video. But let's have a look at traditional computing, the type of computing which is not parallel. So we have the processor here, and the instructions come in and the processor does the processing, and then you have the processed data here. As you can see, there's a queue of new instructions coming in, and the processor is doing its job, and then we get kind of processed data out of it. Now there's a problem with this approach, especially in the past couple of years, and the problem is that we can only make this processor faster to a limit. There is a frequency limit, and the reason there are plenty of reasons actually, but one of the important ones is heat, because these processors are very condensed, so the amount of heat generated by electrons moving through the processor is very high, and that's one of the reasons why we can't really increase the speed of processors, one single processor, because it will melt down. So because of this reason, we had to take a different approach. So if we want to increase the speed, but we can't really increase the speed in one single processor because of heat, then what can we do? So one thing we can do is to increase the number of processors. This way we have two processors running simultaneously, and we divide the tasks between these two processors. This is called parallel computing. Two processors running at the same time, doing the calculations, and we divide the workload between these two processors. Of course, this introduces a new set of potential problems, and one of them is more bugs, because you should know when first which instructions you need to divide and what instructions need to be dedicated to each of these processors. Because let's say that you assign kind of a process to this processor here, and that task gets done fast, but this task is dependent on a process which is currently being run by the other process here. So you can have a kind of latencies, you can have a different kind of problems when it comes to writing programs for parallel systems. Of course, majority of computers, especially since past couple of years, all the computers are running on multi-core processors. So that's another thing. Each processor in the modern computing is called a core. So a quad core, a dual core, that's basically that explains the number of processors running at the same time. So this is a very short video on what parallel computing is. We also have this.
So, that's all for now. Be sure to like this video, subscribe if you want, and if you have any question, please be sure to leave it in the comment section below. Thanks for watching.